right, here we go. Like I said, very short notes today. Expansion factoring. We've been doing it a little bit as we've gone along. I just want to put a couple examples in your notes. So if you're looking for expansion factoring, you have something to look at that's specific. So x to the fourth minus 29x squared plus 100. So when you look at this, even before you start doing ABC factoring, the minute you see an x to the fourth, your brain should go, oh, that's a pretty high power. Am I going to expand this problem? And if I do, it will probably be a squared minus b squared, which is a plus b, a minus b. So that immediately means you should look for expansion. And one of the most missed questions on the upcoming quiz is we forget to expand. We get done and we're like, all done. And we don't notice that, oh, we got to go a step further. So then this is like regular factoring. A is 1. So 1 times 1, that's pretty easy. And then for our C is 100. And we know that it's going to be double negatives. And we know it has to add up to 29 by itself because the A's are 1s. So -1 times -100. If I add those together, I get -101. That's not it. -2 times -50. Add it together, you get -52. That's not it. -4 times -25. Add them together. Yes, we get -29. So those are your factors. So draw your parentheses. Put your A's in the first position. Now, here's where things are a little different. It was an x to the fourth, so we're going to split it. X squared and x squared. And then since it's A's, it doesn't matter where you put the C's, -4 minus 25. So again, the hint that you're going to need to expand is that you ended up with x squareds in your answer. The only answers that won't expand are with things with a plain x. If it's got a plain x, you're done. Good to go. But these both have x squareds. So can we write this first one as something squared minus something squared? Well, x squared is x squared. 4 is 2 times 2. So yeah, we can. So a plus b, x plus 2, a minus b, x minus 2. And those are single x's, so we're done. Now let's look at the second one. We have an x squared minus 25. I can write x squared as x squared. 25 is 5 times 5. So yeah, this one also meets the expansion pattern. So we're going to do a plus b, x plus 5, a minus b, x minus 5. And since all those are now single x's, we are done. You do not have to check for expansion. Okay, so do you always expand both pieces? The answer is no, not always. Let's say that you factored and you got an x squared plus 16 times an x squared minus 9. Yes, they both have an x squared, so you should think about expansion. But if you think about your difference of two squareds, it's only a squared minus b squared. It has to have a minus. So that means that x squared plus 16 is done. It doesn't have a minus in it, so it's not going to expand. So that one's just going to be part of our answer, x squared plus 16. The other one, though, does have the minus, and 9 is a perfect square. So a plus b, x plus 3, a minus b, x minus 3. So if your x squared term has a plus in it, it's not going to expand and you're done. All right, last one, and then we're done. Very short notes today. This one always gets people, and I'm not sure why. X to the fourth minus y to the fourth. So can we write it as something squared minus something squared? Well, yeah. X to the fourth is x squared squared. Y to the fourth is y squared squared. So we're going to use a plus b, a minus b. So x squared plus y squared, x squared minus y squared. Now, just like example 2, the x squared with the plus is done. We cannot go any further. So that is going to actually be in your answer, x squared plus y squared. The other one, though, has a minus and two perfect squares. So yeah, we can do a plus b, a minus b. And in this case, it would be x plus y, x minus y. Those have single x's, so we're done. Any questions about these?